Okay, 11.1, we're going to look at a couple measures of dispersion. A measure of dispersion describes the spread of a data set or how far apart the values are. Okay, the first measure of dispersion is the range. The range of a data set is the difference between the greatest value and the least value, which really just means I do the highest minus the lowest. Example 1, use range to compare data sets. Okay, the table shows the marks out of 10 obtained on quizzes this year by 2 students. So these are Anna's scores, they were out of 10. These are Barry's scores out of 10. Okay, let's calculate the mean, Anna's mean quiz score. Okay, for mean, I can use that little bar at the top. I am going to say A bar equals. Okay, so what do I need to do? I need to add these up. Let's add these all up. I'm going to use my calculator. 6 plus 8 plus 8 plus 14. Okay, so I got 42 divided by how many scores? 1, 2, 3, 4, 5, 6. 6 scores. So Anna's mean score or average score on her quizzes is 7 out of 10. Okay, the range. Range is the highest score minus the lowest score. So her highest score is 8. Her lowest score is 6. So 8 minus 6, her range is 2. Let's look at Barry's data. These are Barry's scores. Let's calculate his mean. Since it's Barry, I'm going to say the mean of B. Okay, so let's add up 5 plus 10 plus, hold on, I can't add and type. I got 33 divided by how many scores? 6 scores. Okay, so his mean score is a 5.5 out of 10. Not quite as good as Mary. Okay, let's look at his range. Range is the highest minus the lowest. So the lowest score he got was a 10. The lowest he got was a 1. So the range in his scores is very high. It's 9. So what's my conclusion? Okay, let's see. Anna's mean quiz score what is it, a little higher than Barry's? Let's say it's a little higher than Barry's. I mean, to be fair, though, Anna's getting a C and he's getting not a C. It's a little higher than Barry's. Okay, what do we think about the range? Anna's range is 2, Barry's range is 9. The range is how far spread out there. Since Barry's range is higher, Barry's scores are much more spread out. But Barry's scores are much more spread out. Okay, that's why Barry randomly gets a 1, then a 10, whereas Anna's mostly getting 6, 7, 8s. Okay, let's do another one. Okay, each list represents how much money each person spent on food for each weekday this week. Carl spent those amounts, Deborah spent those. Let's do the mean and range of Carl first. So Carl is the first data set. Okay, the mean of Carl, I'm going to call it C with a line just to make it easier. Let me add up those values. 13 plus. So I got 49 divided by how many days? 5, which makes sense because there's 5 weekdays. So 49 divided by 5. So he averages 9.8. What is this, money? Oh, that looks weird. So he's spending about $9.80 a day on average. Now let's see what Deborah's spending. Okay, so the mean of Deborah is, let's add up the scores. Okay, I got 57 divided by 5. So 11.4, but this is dollars, so $11.40. So who's spending more on average or the mean? Deborah's spending more. Okay, let's look at the range. Okay, so for Carl, what's the highest? 18 minus 13 is $15 in range. And then for Deborah, the range is 14. What's the lowest? 9? 5. Okay, so what's my conclusion? Okay, Deborah spends more per day on food what happens? Who has a bigger range? Carl has a much bigger range. So the amount Carl spends varies a great deal during the week or is much more spread out. Carl spends per day varies more greatly than Deborah. Okay, or you could say the amount Carl spends per day is much more spread out than Deborah's values. So you never know what Carl's gonna do. He could spend $1, he could spend 20, but Deborah's like $11 within 5. Okay, the second way to measure a spread is the standard deviation of a data set. It's measured how much a typical value in the data set differs from the mean. So we're seeing how far we are from the mean value as opposed to how far spread out the lowest and highest is. Okay, use the standard deviation to compare the data sets. Okay, we're gonna do them separately because it's gonna be much more of a process. This is the formula. It's the square root of x1 minus the mean squared plus x2 minus the mean squared plus blah, 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 divided by n. Okay, so we're gonna do this step by step. So I'm gonna write, what are we doing? Anna? Let me do Anna's scores. Anna got a 6, an 8, a 7, a 7, an 8, and a 6. Okay, now we already calculated Anna's mean. What was Anna's mean? Okay, so standard deviation tells you how much the data set differs from the mean. So her mean was 7. So Anna's quiz score differs from her mean by only 0.816. Okay, and I say only because this is less than 1, and that means her average is a 7, and she's normally less than 1 away from 7, which looks right because she's like 7, 7, 8, 8, 6. She's pretty close to 7 all the time. She's quite close. Okay, now let's consider Barry. Okay, let me write Barry's values in the table. Actually, no, let me go see his mean real quick. Okay, Barry's mean was 5.5, and we did that in the first example, so I'm just copying it. Okay, so I copied his data values here. Okay, the mean was 5.5, so I'm going to do the x value and I'm going to subtract 5.5. So 5 minus 5.5 is negative 0.5. 10 minus 5.5, 4.5. And if you would like to use your calculator, go ahead and use your calculator. I'm going to try to do it by hand, and then I'm going to check to see if I did it right. 9 minus 5.5, 3.5. Okay, now I'm gonna add this column up first to make sure I'm doing it right. It should add up to 0, and if it doesn't, I'm gonna double check my answers. Oh, it did. Okay, good. So this is 0, which is a good sign. So I'm gonna go ahead and square all my numbers. So negative 0.5 squared is gonna be positive, and I get 0.25. And I'm for sure using my calculator. 4.5 squared, 20.25. Okay, I already did 0.5, so let me copy that. 4.5 I already did. 3.5 I also already did. Okay, so let me add up all these values. Okay, so I think it's 65.5. Okay, so now let's find the standard deviation. Okay, let's look back at the formula. Okay, so it's the square root of the sum of all those things I just added up divided by the number of data values. So I got the square root of 65.5 divided by 1, 2, 3, 4, 5, 6. Okay, and even though this looks weird, I'm going to go ahead and put this whole expression in my calculator. You can use divide to make a fraction. Okay, and I got 3.304. Okay, so what does this tell us? It tells us that Barry's quiz scores vary from his mean by about 3.3. So he has a 5.5 to to vary by 3.3 is a lot, because that means sometimes he's at 8.8, and sometimes he's at 2 point something, which looks right because his scores are all over the place. So Barry's quiz scores vary from his mean by 3.304. Okay. And you can tell his scores are all over the place. If this was a test out of 100, 3.3 wouldn't be that much to vary. But since it's out of 10, that's quite a lot to vary by.